All right, let's test out that understanding. We are using the parallelogram. So I'll draw my parallelogram in red, and then our resultant vector goes from the same spot to the other corner. So it's in the first quadrant going at about, like, I don't know, 80 degrees? Not quite 90, because 90 would be exactly on the y-axis, right? Next one, draw a parallelogram. And then the resultant. Exactly on the negative x-axis. There you go. What's next? Parallelogram. Is this stuff easy or what? Why can't it all just be this, right? And then your resultant vector from the origin to the corner. There you go. Now we're going to use the tail to tip method, which is going to be a lot more difficult for me, but so I will try to do my best. It looks like we go to the right 1, 2, and then we go up 3. So I'm going to go to the right 2 and then up 3. So there's my tip. There's my vector A. Now I'm going to take vector B, which goes to the left 1, 2, 3, 4, and up 1. And I'll get you a different color. For vector B, 1, 2, 3, 4, and up 1. There you go. There's that. And then finally, the resultant vector connects the ending to the starting. And we ended up going that direction. So because vector B is longer than vector A, we're going to be influenced by vector B quite a bit more. Right, so next one, vector A, we're going to go to the right 1, 2, 3, 1, 2, 3, 4, and then down 2. Green is my vector A. Yellow will be vector B, which I will take this vector that goes down 1, 2, 3, and to the right 1. To the right 1. There's my vector B. My resultant vector is going to be from my start to the finish. So that blue is the resultant. Next, oh boy, we've got this mess here. No big deal. We're just going to draw it like we would. We have to figure out a kind of reasonable starting spot because this is kind of limited here. So the first thing that I would do is I would go ahead and just label these. So we'll have vector A, B, C, and D, or whatever you want to call it. But we'll just do that. Yeah, so let's go ahead and start vector A at the origin. It goes up 1 and goes to the right 3. So we're right here. That is going to go down 2 and to the right 4. Well, if we go down 2, 1, 2, and we go to the right 4, we ran out. I messed up because I started at the origin, right? I should have started over here. But that's okay. Let's just go ahead and do vector C. Let's see if we can do that one. 1, 2, 3, down. 1, 2 to the left. That seems reasonable. 1, 2, 3 down. 1, 2 to the left. So here we are, right at that spot. We can try vector B now. Let's go ahead and do vector D. Vector D, we're going to the left, all of them, it looks like. So 5, and then we're going up 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Vector B goes down 1, 2, and to the right 1, 2, 3, 4. Down 1, 2, and to the right. 1, 2, 3, 4. Hey! They just connect! That's all. So, if this were displacement, we would say there was 0 displacement, right? After all of that movement, we still ended up right back where we were. If this was force, we would say there's no net force acting on it, because you have all of these vectors pulling on it in different directions, but all of them canceling each other out in the end. We'll look more at that in future lessons.